Welcome back to Unit 8. We're going to be continuing our discussion about proportions and percents, and now we're going to talk about how we can solve proportions if we're missing one piece of the proportion. So let's go ahead and get started by looking at a few key ideas. So a couple of key ideas that we have to remember when we're talking about proportions is, remember, a ratio is when we compare one thing to another, and two equal ratios are what give us a proportion. Knowing that, we can now use that information to solve proportions. So let's take a look at example A. So here we are in example A, and it says that we're going to be solving this proportion. 8 over x is equal to 6 over 15. And when we solve proportions, we need to use cross multiplication. So when we're solving proportions, we use something called cross multiplication. So let's see that in action here. So I'm going to cross multiply my x to my 6 and my 8 times my 15. So notice I cross multiplied. So I crossed from the top to the bottom across, making an x. So 6 times x is going to give me 6x, and 8 times 15 is 120. So notice I'm going to continue to keep the things equal because I'm still talking about two equal ratios. So now I've got 6x equals 20, and I've got myself a one-step equation. But good news, I know how to solve one-step equations. I'm going to go ahead and draw my wall down for my equal sign. Then I have 6 times x, so I need to use my inverse operation. So my inverse operation of multiplication is division. So I'm going to divide both sides by 6. 6 divided by 6 is 1, or 1x. And 120 divided by 6 is going to give me just 20. So x equals 20. So another way to look at this is 8 over 20 is equal to 6 over 15. And now I have an equal proportion. Now let's take a look at example B. Here we are at example B, and it says we've got a proportion again, but this time I've got 3.5 over 4 is equal to x over 20. And when I'm solving proportions, remember that I'm going to use cross multiplication. That's always something I want to use when I'm solving proportions. So I'm going to start by cross multiplying 4 times x and 3.5 times 20. So 4 times x is going to give me 4x, which I can see. And 3.5 times 20 is going to give me 70. So now I've got 4x equals 70, and I've got myself a one-step equation. But the good news is I know how to solve a one-step equation. So I'm going to draw a wall down from my equal sign. I have to perform the inverse operation. So again, 4 times x, the opposite of that is divide by 4. I'm going to do that on both sides of my equation. 4 divided by 4 is 1, or 1x. And 70 divided by 4 is going to give me 17.5. So now when I write out my final proportion, I know that 3.5 over 4 is the same as 17.5 over 20. Now that we've solved some standard proportions, we're going to start incorporating this into different scenarios. So the first scenario problem that we need to talk about is a shadow problem. So let's take a look at example C and shadow problems right now. So here we are at example C talking about shadow problems. And it says a utility worker is 5.5 feet tall and casts a shadow 4 feet long. At the same time, a nearby tree casts a shadow 20 feet long. Write and solve a proportion to find the height of the tree. So let's go through our problem first and find our important information. So knowing our utility worker is 5.5 feet tall and casts a shadow 4 feet long is important information. We also need to know that the tree cast a shadow 20 feet long. So now that we have multiple pieces of information, let's set up our proportion. And remember, a proportion is just comparing two things. So in this case, we're going to be comparing height of how tall something is to the shadow's length. So the height versus the shadow. So how tall the person or the tree is versus the shadow, how long it is in the tree and the man. Since the two things we're comparing are the man and the tree, let's grab ourselves a man here and grab ourselves a tree. Now, this is just details to help make sure that we set up our proportion correctly. Notice there aren't any lines here like there were in the last problem with our proportion already set up. We're going to have to come up with those lines ourselves. So these tools of drawing a man and drawing a tree, or using emojis in this case, is going to be helpful to help figure out how we set up our proportion. It's not necessary, you don't need it all the time, but since we don't have any lines here for ourselves, we're going to make sure that we keep the man on one side and the tree on the other. There's lots of different ways to set up the proportion. I could switch the tree and the man. That doesn't matter as long as I keep the man on one side, the tree on one side, the height on the top, and the shadow on the bottom. I just have to make sure that everything is in the right place. So now we're going to draw some lines for our proportion. So we've got a line here for the man, an equal sign, and a line here for our tree. So now we got to figure out the height of our man. It says in the problem is 5.5, so we're going to put that on the top. Then we need to figure out the height of the tree. The problem doesn't tell us the height of the tree, so that's going to be our x. Then we need to figure out the shadow of the man, and the problem tells us that's going to be 4 feet. Then we need to figure out the shadow of the tree, and that tells us that it's 20. So notice, we went through the problem, we figured out what things we had, which things we were missing, put everything in our proportion, and now it looks like our proportions from problem A and B. So I'm going to start with our cross multiplication. 4 times x is going to give me 4x, and 5.5 times 20, again, if you don't know how to do that in your head, you can use your calculator, is going to give us 110. Now we've got a one-step equation, but lucky for us, we know how to solve one-step equations, so we're going to go ahead and draw a wall down from our equal sign. We're going to use the inverse operation of multiplication, which is going to be division. 4 divided by 4 is going to give us 1, or 1x, and 110 divided by 4 is going to give us 27.5. But this is a word problem, so we're going to need some sort of word answer. So in this case, we have a 27.5 feet is how tall our tree is. So 27.5 feet tall tree, so that we know we're talking about the tree. Sometimes it won't tell us to write out that we're talking about the tree because the problem already talks about find the height of the tree. So obviously whatever your answer is going to be is about the tree. However, you do need to make sure that you label your answer with feet, or whatever height or marking, flowers, cup, whatever you're talking about needs to have a label. It has to have a word answer to our word problem. Now let's take a look at example D and E, where we'll be talking about unit rate. So here we are talking about unit rate, and unit rate is just stating how much it is for one of something. So if you're talking about buying 12 rolls of toilet paper, a unit rate would be how much does it cost for just one roll of toilet paper. So now we're going to look at a couple of examples of figuring that out. So example D starts with a motorcycle that can travel 39.7 miles on 1 gallon of gas. So using our unit rate, or figuring out what that is, we need to figure out how many miles it can travel on 3 gallons. So let's go through and highlight our important information first. So 39.7 miles on 1 gallon of gas is important information, and we need to figure out how far it can travel on 3 gallons of gas. So we're going to set up our proportion by figuring out the two things that we're comparing. The two things that we're comparing in this case are miles and gallons. How far can that motorcycle travel on gallons of gas? So again, we don't have any lines here for our proportions, so we're going to have to set them up ourselves. We could draw little motorcycles and little gallons of gas cans if we wanted to, or use emojis to do that like we did last time, but that's probably not going to be something that we want to do every time that we solve a proportion problem, is draw little pictures ahead of time. So we're going to try and do it without it. We're going to just need to make sure that we keep one thing on one side and one thing on the other. So let's start with what we have. We have 39.7 miles. So we know that that's going to go in the miles category. Then we need to figure out what's that going to compare to. Well, it's going to compare to 1 gallon of gas. Then it's asking us how many miles can it travel on 3 gallons. So since it says 3 gallons, I'm going to put that on the gallons side of my proportion. And I don't know how far it can travel, so that's going to be our x. Now that I've done that, I can set up my proportion, or my proportion is set up, so I'm going to begin my cross multiplication. So 1 times x, and then 3 times 39.7. So 1 times x is x, and 39.7 4.7, again, if you can't do that in your head, please use your calculator, is going to give us 119.1. Now, I would go about solving my equation, but I already have x isolated. I already know what x is, so I don't have to do anything else. I just need to tack on the answer to the end of my problem here. And since we were talking about word problems, we were talking about how many miles it can travel. So 119.1 miles is how far this motorcycle can travel on 3 gallons of gas. Now let's slide down there to example E, where it talks about the cost of tuna. So it says tuna costs $4.68 for 12 ounces at the local supermarket. How much does it cost for 1 ounce? So again, let's go through and pull out the important information in our problem. So $4.68 for 12 ounces, and then how much does it cost for 1 ounce? So the two things we're comparing in this problem is we're going to be comparing dollars to ounces. And again, you can put the ounces on top and the dollars on the bottom. It doesn't matter as long as you're keeping everything lined up. So now that I've done that, we're going to have to create our own little proportion because it doesn't do that for us. And we have to go and put in the information that we already have. So we know that it costs $4.68 for 12 ounces. Okay, so the ounces that we know is going to stay on the left-hand side. I kept those things together. Then on the other side of my proportion, I don't know how much it costs for 1 ounce, so that's going to be my x, and since we're trying to find 1 ounces, that's what's going to be on the bottom. Remember, unit rate is always trying to figure out 1. So if it doesn't tell you what one of the pieces of your information is, but it's talking about a unit rate, then you know you're looking for 1. So now that our proportion is set up, we're going to cross multiply. So again, 12 times x is 12x. 1 times $4.68 is going to be 4.68. Now this time I am going to have to solve an equation. So I'm going to draw my wall down from my equal sign. I'm going to divide both sides by 12 because again, I have to do the inverse operation. 12 divided by 12 is 1 or 1x. And then 4.68 divided by 12 is going to be 0.039 or 0.39. So that has solved my problem. However, this is a word problem, so I need a word answer. And since we were talking about dollars and ounces, we were looking for the amount it costs, so we can put a little dollar sign up there. We don't have to write anything else because we're talking about it costing 39 cents. Then you can circle your answer if you want because that'll be easily identifiable on your paper. Now let's take a look at example F, where we'll be talking about scale drawings. Here we are at example F, and it talks about scale drawing. So a scale drawing is when you go ahead to make something of a very large scale, like a building or a car. People don't just go out and start constructing the building with no pictures. They usually have a scale drawing because you cannot draw a picture to the same size as a building or the same size as a car. It would be gigantic. It wouldn't fit in your pocket. You'd have to fold it 1,000 times. So to do that, they use something called scale drawing, where you shrink it down and then move it up to scale accordingly. So now let's take a look at our first problem there. And it says a model of a 27-foot tall house, that's probably going to be important, was made using a scale drawing of 2 inches to every 3 feet. How tall is the model? So they want to know how tall is the little model they made ahead of time before they went and started building the building. So the two things that we're going to be comparing in this problem is we're going to be comparing the inches to the feet, because the house is 27 feet tall and the scale drawing is in inches because it says 2 inches in our problem. So now that we've done that, we're going to go ahead and draw out our proportion because there isn't one there for us. So we're going to have to plug in our information. So it says the house is 27 feet tall. So is that going to go on the top with inches or on the bottom with feet? Since it says feet or foot, it's going to be at the bottom. I don't know how tall that model is though in the comparison of the house, so that's going to be our x. Then it tells us the scale drawing is 2 inches to every 3 feet. Notice I put the 2 for the inches on top and the 3 for the feet on the bottom because that matches up where I'm keeping my inches and keeping my feet. Now that I've done that, I can do my cross multiplication. 3 times x is going to give me 3x. And 2 times 27, again, if you can't do that in your head, feel free to use your calculator, is going to give you 54. Now that we've done that, we do have to solve this equation, so we're going to draw a wall down from our equal sign. divide both sides by 3. Remember, the inverse operation of multiplication is division. 3 divided by 3 is 1, or 1x, and 54 divided by 3 is going to give us 18. But again, it's a word problem, so we need a word answer, and the area that we were missing is on the inches side, so this is going to be 18 inches, and you can abbreviate. Now let's take a look at another scale drawing problem. In this problem, it says the length of an object on a scale drawing is 2 centimeters, and its actual length is 8 meters. The scale is 1 centimeter to we don't know. So in this particular case, they've given us the model, they've given us the actual, and we need to figure out what the scale was. So we're going to go through our piece of information here, our problem, figure out our important pieces of information. Scale drawing is 2 centimeters, the actual length is 8 meters, and our scale is 1 centimeter to we don't know. So the two things that we're going to be comparing, since it talks about the actual length in our problem, our scale drawing being centimeters and our actual length being meters, those are the two things that we're going to be comparing. We're going to be comparing centimeters to meters. So it's always important to go through your problem and figure out the two things that you're comparing. Sometimes there'll be misleading things, like it might talk about dollars, flamingos, and cats, and you don't know. You have to make sure to figure out which thing you are comparing. So now that we know that, we're going to draw some lines because we're going to have to set up our proportion for ourselves. So they've told us that the scale drawing of this item, whatever this item is going to be 2 centimeters, and its actual length is 8 meters. So that kept on the left-hand side because we're talking about whatever the object is. Then on the other side, we're going to try and figure out what the scale is. They haven't told us, but we know that it has 1 centimeter, and we don't know the meters, so that's going to be our x. Now that we have that information, we can cross multiply just like we've always been doing to solve our proportions. 2 times x is 2x. 8 times 1 is 8. Now that I've got an equation, I can go ahead and solve that by drawing a wall down from my equal sign. 2 divided by 2, because again, we're going to be doing the inverse operation. Do that on both sides of our equation. 2 divided by 2 is 1, or 1x, and 8 divided by 2 is 4. But again, this is a word problem, so I need a word answer, so this is going to be 4 meters, and we can fill that in our problem up above. That brings us to the end of these set of notes and this video. So if you've liked this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.